Okay, so now we're going to take a look at part C from question 25. So here we're told Jill wants to be able to make at least 100 withdrawals. What is the largest value of M that will enable Gia wants to make 100 withdrawals. What's the largest value of M that will enable Gia to do this? Well, essentially, in this case, you want the amount after 100 withdrawals to be equal to 0, right? After she's made 100 withdrawals, you want nothing left because that means she's able to make 100 withdrawals. Now we just calculated a formula for AN. We identified that AN was in fact equal to 10,000 minus 250 times M, which is the withdrawal, times 1.004 to the power of n plus 250 times m. We're going to set this equal to 0 and we are going to solve. So this gives us A100, which we know is equal to 0. Now A100 implies that n is 100. This is 10,000 minus 250 times m times 1.004 to the power of 100. 1.004 to the power of 100 plus 250 times m. So we've got to solve for m. Well, we'll add 250m to both sides, or we'll subtract 250m from both sides. It gives us minus 250m is equal to, and if we expand these brackets, we can have 10,000 times 1.004 to the 100, and then we can have minus 250m times 1.004 to the 100. So this is now just a numeric term. Both of these contain m's though. So we'll move this other m containing term to the other side. Add 250m times 1.004 to the 100 plus 250m times 1.004 to the power of 100. This gives us 250m times 1.004 to the 100 minus 250m is equal to 10,000 times 1.004 to the 100. If we factor m from everything on this side, we get m, and then divide by what's left. We get m in front of 250 times 1.004 to the 100. So anything that's next to these are all multiplied. I'm just omitting the multiplications to fit it on the page properly. Minus 250 ends up being equal to 10,000 times 1.004 to the 100. Divide both sides by this. This tells us that m is going to be equal to 10,000 times 1.004 to the power of 100 divided by 250 times 1.004 to the power of 100 minus 250. Now we need to put this into the calculator. And because this is dollars and cents, we're going to have to round this. So we have, this is quite a long expression, so be very careful when you're putting these in. 10,000 times 1.004 to the power of 100 divided by 250 times 1.004 to the power of 100, all minus 250, gives me 121.5270 ... So this is the answer. Now, if she wants to be able to make at least 100 withdrawals, she needs to withdraw slightly less than this. And so therefore the answer M is actually going to be 121.52. So this is at least 100 withdrawals. This means there will be some lingering amount left in the account for an extra withdrawal, right? We solved it as if it was only 100, but then at the end we took into consideration the fact that the question asked at least 100. So this is the answer, and this is to, essentially you're rounding it to the closest lowest cent, right? It would be the sort of financial theory rounding. But this is the answer in terms of dollars and cents. Right? And this is the answer that we're after for this question. So now, this is worth 2 marks. Let's talk through the marking. So you have to to get the first mark, you have to either identify something along the lines of an has to be greater than 0, or n has to be equal to 100, or some equivalent merit, and you have to start solving. So setting an equal to 0 and then solving it. You can do it as an inequation, or you can do it as an equation. It doesn't really matter. It's going to get you the same answer. If you do it as an equation, you then have to consider the rounding at the end. If you do it as an inequation, you'll end up with an inequality at the end, and then that will tell you what the answer is. But to get the answer mark, you need $121.52. Now keep in mind, if this question was done, this is really a finance question. If this question was done in a financial context, you could get a range of different answers. You might get answers that vary up or down by a number of cents, depending on how these values are calculated. So don't imagine that this is necessarily going to be the correct solution to this question in every context. The answer will vary depending on how it's calculated.